finding an inverse function, we take the function that we have and we flip the x and the y. Okay? Because inverse functions reverse the input and the output from the original function. So if we reverse the input and the output, okay, x equals 2 minus y over 2y plus 1, this essentially is the inverse function. But we don't like it in this form. We want y equals some function of x. And so we're going to start by multiplying both sides of this by the 2y plus 1. And then we're going to multiply this x in. So 2xy plus x equals 2 minus y. Now our goal is to solve for y. So anything that has a y, we're going to put on one side of the equation. Okay, so we have a 2xy and then plus y by just adding this y over. And then the other things we're going to put on the other side. And so we have to subtract the x over. So 2 minus x. Now since we're solving for y, we can take the y out of this side. Factor it out. And then divide by that 2x plus 1. And so we end up with y equals 2 minus x divided by 2x plus 1. Now this is f inverse of x that we have found. You'll notice something quite interesting has happened here. We ended up with the original function. Now that is actually quite a rare occurrence. This only happens if a function is symmetric about the line y equals x. And so it happens quite rarely, but it does happen. Okay. And so if we were to graph these, there's our line y equals x. The graph of the function and its inverse are the same because this function is symmetric about this line. So this line kind of acts like a mirror for that function.